The third area to have literacy in is machine learning. Now, this talk is not going to spend an hour explaining machine learning. This is a very simplified version, but it includes the concepts that matter the most when we're talking about safety. Machine learning, in a nutshell, is you first feed a system a lot of data. We don't necessarily know how to write a particular software function by writing source code, so instead we say, well, we're just going to train it up on a bunch of data. We're going to show it a bunch of examples and let the machine learning figure out what the right behavior is. So it learns statistical properties. This is an important point. Machine learning does not learn the way a person learns. They don't learn to reason. It doesn't learn to think through. It doesn't learn to build internal physics-based models, at least with typical machine learning. Rather, it learns statistical properties. You can show machine learning a bunch of people's faces, and it does not say, oh, I know what a nose is, I know what a chin is, I know what an ear is, but rather it builds up statistical relationships that says, well, that image is statistically similar with a bunch of features to things that I've been told are a face, so it must be a face. And it generates statistically plausible results. There are different flavors of machine learning. One of them is classification. Is it a car? Is it a person? There's a family movie called Mitchells versus the Machines where the family dog, who's obviously sort of a weirdly animated dog, is it a dog? Is it a pig? And the machines all decide it's a loaf of bread as a plot device. Now, what's important here, they're not saying it's really a loaf of bread. Obviously, it's not a loaf of bread. What this classification is saying is that image is statistically more similar to a loaf of bread than to a dog or a pig. So when a machine learning system sees a human face or sees a particular person, it does not know that's a person. It doesn't know what a person is. What it's saying when it says, oh, that's a person, is that thing I'm looking at is statistically more similar to people that I've been trained on than other things I've been trained on. And that's an important difference. There's also generative art where you can take a random set of noise and you can say, well, how much catness is in there and how much Picasso-ness is in this picture? And then you can randomly perturb it and say, well, that version has a little more cat in it, a little more Picasso in it. And if you do that enough times in a row, you end up with a picture that looks kind of like a cat drawn as if it were drawn by Picasso, even though it's a completely synthetic image. Obviously, that's a simplified example, but the idea is you can generate things that statistically are similar to the thing you wanted, even though it's not an authentic image of anything in the real world. A third flavor of machine learning is large language models or foundation models, which predict the next likely output in a sequence. You can say it was a dark and stormy, and the most likely word in the English turns out to be the word night. It was a dark and stormy night, but it could be other words. And it's a little more sophisticated than that. It has tremendous ability to take context, sometimes of tens of thousands of surrounding words. And so what it produces is very sophisticated mimicry of things like language in LLMs, or things like what's the next picture in a video of a car driving down the road as seen from the driver in a vision-based foundation model. All three of these things can produce really impressive results. They're statistically very sophisticated, amazingly capable systems. But they're not artificial general intelligence. They don't actually think the way people think. And I understand this point is contested, but where I'm coming from, they don't think the way people think. They don't reason the way people reason, even though they say they're reasoning. That's not what's going on. They are statistical models. And so the important thing is, it's a mistake to attribute to them thinking. Rather, they're statistical mechanisms that can do really impressive, capable things, but don't go too far and don't assign them agency and don't assign them thinking. There's a famous test called the Turing test, in which if you're chatting with something over a typewriter keyboard and display, you can decide whether or not you think the thing on the other side is a machine or a person. And if it's a machine that convinces you it's a person, it passes the Turing test. But the thing is, we've known since a project called ELIZA back in the 1970s that some people are very susceptible to believing something's a person when it's really a machine. And it turns out that the Turing test is more of a measure of gullibility of the person on the other end of the keyboard than it is as to whether the machine has real intelligence or is just really good at faking it.